Hi guys, I'm Tal, and this is a look at how to create a Linux service using Python. So the first thing we're going to do is cheat by cloning my Git repository here. I'll leave this link in the description. If you don't have Git installed, you can either go directly to this link in your web browser and download the files that you need, or you can install Git with the package manager of your distribution, whether that be apt or yum or dnf. The package is usually just called Git, so just go apt get install Git or yum install Git, and then just run this exact command. Once you do that, in your home directory or in your current directory, you'll have this folder now, and this will let you get started really quickly. So the first thing you're going to see is all of these files. You can see the README on the GitHub page directly, and it'll basically list the steps that we're about to take. So first we're going to create a directory called opt my service. We're going to copy the lib file and the service.py file to the directory, and then we're going to go into the main scripts directory here, and these are examples of different services. The simple one is what we'll be looking at today, but we also have a TCP server sample service and a Unix sample service. If you guys are interested in that, you can have a look at that. So I'm just going to copy this simple main.py to my service. And one more thing I'm also going to do is rename it while I'm copying it. So I'm not just going to keep it as simple main.py, I'm going to rename it to main.py. Okay, now if we go into my service, we see three files in here, the lib.py, main.py, and service.py. So the main file that starts up is service.py. And we'll just have a quick look at it. It has the shebang up here to let the system know that it's a Python 3 script. We have some imports. We have some global variables. Those global variables, one of the main ones is the debug variable here. And that decides if debug print statements will be printed or not. So if we're running in debug mode, certain print statements will be printed to either standard out if you're running the script directly, or to the systemd's logs if you're running it through systemd. And if debug is false, then it won't print those statements. The main thing that decides if debug is enabled or not, well, there's two things. Either the environment variable, if you set an environment variable called debug, then if you set that to true, then debug will be enabled. If you set that to false, it'll be disabled. But if you don't set that environment variable, then what this script will look for is whether you're running this script directly through a terminal or whether systemd is running it. So if you're running it directly through a terminal, debug will automatically be enabled. And if you're not running it through a terminal, so systemd is running it, then debug will be disabled. I kind of like that because normally when I'm running it in a terminal, then I want to be debugging, I want to be working on something and fixing something, whereas if I'm running it in systemd in the background, that is more of a production environment where I don't want a bunch of debug variables, I just want the important variables when something happens. So that kind of makes it automated. I don't have to switch debug on and off. I just either run it by systemd or myself, and it just automatically knows which statements to print. We have the script name here, which is useful in some places. We have a logger. So instead of doing print, and if you've been working in Python for a while, when you start out, the first thing you're gonna do is do print statements, just regular print something. But if you have some print statements that you want to print in a debug environment and some you don't, you quickly end up with something like if debug print, and then that starts to look really messy. So with a logger, if you've never used Python logging before, you can do something like logger.debug. Or so this logger.debug will only be printed if our debug global variable is true, whereas this will always be printed. So it's really easy to just have a single line, and it'll know when to print it and when not to print it based on if this debug variable is set or not. So I find that really useful. So here we initialize the logger. We just say that it should print to standard out and standard error, which means if you're manually running it, it'll print to the terminal, but if systemd is running it, it'll go into systemd's logs. We're also setting the log level depending on if debug variable is set or not. So here, if debug is set, we're setting it to logging.debug, which means, like I just showed a second ago, any logger.debug messages will be printed, whereas if you have logger.setLevelInfo, so if if this debug global variable is not set, then we set it to info, which means debug level logger.debug statements will not be printed. There's also logger.warning, logger.error. Those will always be printed because they are higher priority than debug and higher priority than info, so those will always be printed if that's something you want to use. We also have a kill signal handlers, one for sigint and one for sigterm. So what that means is when you're running your Python script in a terminal, if you've ever hit Control-C to interrupt the script, you might have seen the traceback, which is a bunch of lines that say where Python was when it got interrupted. And it looks kind of ugly and it looks unprofessional when you have, it kind of looks like an error when you try to interrupt it with Control-C. And if you want to handle that, most of the time you don't really care what Python was doing when you tried to interrupt it. So if you want to handle that in a nicer way, what you need to do is the other way to do it that some people use is having the entire code in like a try block and then catch the exception that gets raised when you hit Control-C. I don't remember the name of the exception, but there's an exception that gets raised. But then your entire code needs to be within a try block, and that looks really messy too. So this is a simple asynchronous way to do that. You just do signal.signal, and then you say if the program receives a sigint, which is the interrupt kill signal, which is our program receives when somebody hits Control-C. Then we want to call this signal handler function. And the signal handler function is defined right here, and it just says exiting and sys.exit. This sigterm does exactly the same thing, except for in systemd, when systemd is running your script as a service, normally the way that you would stop your service is going systemctl stop and then the service name. What that does is not send you a sigint, but that sends you a sigterm instead. So here we're handling both sigint and sigterm. So I kind of like that, where instead of showing a traceback, it just says exiting, and it exits nicely and quietly. Another thing we have is this check if another instance is already running. A lot of times I'll have my script running in the background with systemd, and then I'll try to work on my script in the terminal, and I'll forget that systemd is running my script in the background. And if my script is doing modifications to a database, for example, I'll be trying to figure out why the database is getting hit twice. So if my script is making a change to a particular column in some table, I'll be trying to figure out why that change is doing something that I'm not expecting, and it always turns out that I have systemd running my script already. So I kind of came up with this quick code that tells me if my script is already running. So if you try to run your script in the terminal and systemd is already running it, it'll basically just print an error that says another instance of your script is already running, and it'll exit out, which I find pretty useful. If you guys don't, you can get rid of this section, but it comes in handy once in a while for me. For main, this is, so as a service, what you want to do is have your script not exit unless something crashed. So services run for extended periods of time, and there's different types of services. If it's a TCP service, then the way it will not exit is by having a blocking operation that listens on some socket. You can see in my other sample with the TCP server, but in this case, in the simple case here, what I have is a looping service. So what it's going to do is loop infinitely. It's going to do some operation. For example, it's going to go online and check the current weather. And then if that weather happens to be, if the temperature happens to be like really hot, then it can do something, and then it will wait a while, and then it'll run the loop again. It'll check the temperature again. So this is something that I've used quite often, where it loops every, let's say, 60 seconds or every 5 minutes. It checks something. Depending on the result of that check, it does something, and then it waits again, and then it checks again, and then it does something again. So it kind of loops and makes decisions of what it should do. So that's something that comes in handy quite often. So that's my simple script. And one thing that you'll notice here, this entire section could have been replaced by a simple sleep 60, for example. The reason I didn't do it that way is because if you have this, what you'll end up doing is when you start your script, even in debug mode, it's going to take 60 seconds before your main code runs. So it's really annoying when you're trying to debug it, and then what you'll end up doing is like either deleting this or setting it really low and then forgetting that you have this set, and then you'll commit it to your Git repo, and then you'll be really annoyed because you'll have to fix it, or in production you're going to end up with a script that runs every 3 seconds. So what I have instead is a script that knows when it's running the first time. So first run equals true, and it says if this is the first run, just set that the first run equals false, and it skips this else code, and it'll run your main code right away. So what that ends up doing is the first time that you run your script, it runs your main code right away, and then it comes back for your second run, and then it'll do one of these time.sleep statements. So if debugging is enabled, then what the length of time that it'll wait is this debug sleep time, which is defined up in the global variable section at the top of the file. Debug sleep is 10 seconds. But if we're not running in debug mode, then it'll wait this amount of time, which is 60 seconds. So you can kind of play around with those, but I like it where even when I'm debugging, if I want to see how the script performs over time, I don't want to be waiting 60 seconds or 5 minutes between each run. I want it to run really quickly. So in debug mode, I set the timer that it waits between iterations really short, like 10 seconds or 3 seconds or whatever you want. But in production, it'll be whatever I wanted. Because in production, a lot of times, if you're hitting some kind of an online API, it might have limits on how quickly you can hit it. So you don't want to be hitting it every 3 seconds and then get banned or anything like that. So yeah, 2 different timers here. Then we have our main code, and our main code runs in a try block. So we run our main code, we'll see that in a minute, and we have the this except exception that catches all exceptions, which means that if any exceptions get raised by the main function here, it will catch it, and it'll do 2 things. It'll send it to the logger.error, and it will send an email alert that there was an exception raised. So when your service is running, what you don't want is for it to crash all the time. So for example, like I said, if your service is checking online for the current weather, if for a couple minutes you happen to not have internet, then this main function might raise an error when it tries to reach the server to check that API. So when that exception happens, it will send you an email alert, and it will also log that. So maybe if you do lose internet, it'll probably fail to send you the alert, but if there's any other kind of error, then it will send you an alert. But it'll also log that. So not only will it keep running and keep trying, but it'll also let you know that, hey, something crashed, you should probably take a look at that. If it's an important crash, then you want to take a look at your code. If it's not an important crash, then you might want to ignore it, maybe because you were expecting to lose internet or something like that. One thing you'll see here as well is this format exception for journald. So what we log with this logger.error is the actual traceback of where the error happened. The traceback is, you've probably seen a traceback from Python before. When you hit Control-C normally without catching the sigint, it shows you the traceback of exactly where something crashed, or if you've ever raised an exception without catching it, you'll see where it crashed. So that's the traceback. The thing is that traceback is a lot easier to read when it has indentation. And when you log something to journald, which is systemd's journal logging system, it removes the indentation from every line, which is really annoying. It's really hard to look at tracebacks when it does that. So what I have here is a function that I defined. You can have a look at it. It's a fairly short function, but basically for every line of the traceback, it adds a dot at the beginning of the line, which tricks journald into not removing the initial white space for every line, making tracebacks really easy to read in the log file. So I kind of like that as well. And we have this send alert, which also sends us an email. And these are all defined. So these two, format exception for journald and send alert, are defined in lib.py. And the main is just defined in main. So you can see up here, main is coming from main, and send alert and format exception for journald is coming from lib. So basically, when you want to run a service, depending on how much you want to change this, if you're happy with all this, you really don't even need to change service.py, unless you want to customize it and maybe clone my repo and have your own version of service.py. But the main thing that you need to worry about is just changing main.py, and that's what your code actually does. So here you want to have logging and import logger so that you can print statements as well. And then you want to have a main function, and this is where your code goes. So my sample main function, what it does is just keep track of how many times it's run. And if the current run is a multiple of 3, it will raise an exception. And if not, it'll just say running our code and keep going. So for demo purposes, let's see what that looks like. I'll run service.py. So the first time it runs properly, and it's going to wait 10 seconds. It knows that we're running from a terminal, so it's printing debug messages. And it's only waiting 10 seconds because we're running from a terminal in debug mode. So that's the second run, and on the third run, there's an exception that's going to be raised, and we'll see what that looks like. So here we go, we had an exception. It printed the exception to the terminal, and it's also sending an email. So right now, if we take a look at my lib.py, the send alert function, which takes a traceback and the destination where you want to send the email, really only hard codes the subject, has a simple body. Our service ran into an issue. This is the traceback. It appends the traceback, and it calls send mail. Send mail is defined down here, and that's what's expected to send the email. I might do another video of how to actually send the email through Gmail using OAuth, but for now, all it does is just print the email it would have sent to the screen. So here we have sending email, and it says what it was going to send. Our service ran into an issue. This is the traceback, and then so this is the exact email it would send. So yeah, that's pretty much what the code looks like. So now let us run it through systemd. So a lot of times you're going to have your service require third-party modules, Python modules from PyPy. So let's see what that looks like as well. Going to go back to my repository, and we have a requirements file here. So this requirements file, if you've never dealt with one, lists all the requirements that your project is going to have. So let's do this. First thing we're going to want to do is create a virtual environment. In Python, the recommended way to run Python is through the use of virtual environments, where you install Python modules from PyPy. So the way that would be done is Python 3 mvenv. So we're calling Python 3, we're telling it that we want to use the venv virtual environment module, and then we specify where we want to create the virtual environment. And the virtual environment is basically just a folder where it'll store the Python modules that are installed from PyPy. So what we're going to specify is my service venv3. Hit enter. This will take a few seconds. So now that our virtual environment is created, the way that we enter the virtual environment is by going source opt my service venv3 bin activate. So this didn't look like it did anything. On some terminals, it'll actually let you know here somewhere on this line that you're inside the virtual environment. Like Bash will let you know, mine currently doesn't. But what I can do now that I'm inside the virtual environment is use pip to install Python modules from PyPy. So I'm going to do pip install upgrade pip. So usually pip is an older version, so I like to upgrade it as the first thing that I do. And then we can do pip install. So just as an example, we can do, for example, Django. So if I deactivate the virtual environment and I go into Python 3 and try to import Django, you can see that it can't find it. But if we activate the virtual environment and I do the same thing, import Django, it does find it. So just as a proof that when our systemd is running, we want to run it through the virtual environment, I'm going to open main.py and I'm going to do import Django. So this means that when we run our service, if it can't find Django, then we know we're not running in our virtual environment, but if it can, then we are running in the virtual environment. We're not actually using Django anywhere, it's just an example of a package from PyPy that we want to use. Okay, so I'm going to go back to my Git repository and I'm going to copy this myservice.service. This is a systemd service file that specifies how to run your Python module as a service. And we want to copy it to etc systemd system. So this will let systemd know that we want to run our service. Let's have a look at it. So there's a couple of things in this file. First, the description. You can change this to whatever you'd like. We can also specify which user to run your service as and which group to run your service as. The type of the service that we have is simple service. And then we have this exec start line. And that's the most important line that tells it which service to actually run when the systemd service starts up. So here you'll see two things. You'll see that we're executing Python 3 from within our virtual environment. So we specify the exact path to our virtual environment, and then inside of that we have bin and then Python 3. So this tells it to actually run the virtual environments interpreter. And then we have the path to our script. The next thing we have is this environment variable, Python buffered. So Python does line buffering, which makes it not show up in logs. Anytime that it's printing, doing print statements or printing it as part of logger.debug or logger.info, if you don't have this set, it's probably not going to show up in your logs. So for Python, this is very good to have if you want your output to actually show up in your logs. The next thing that's commented out that you can set, so because we'll be running our script through systemd, and our script is smart enough to know that when it's running in systemd, we want debugging to be off. if you do want at some point to enable debug mode while running in systemd, what you can do is uncomment this, and this sets the debug variable environment variable to true, and this will force the script to run in debug mode even though systemd is running it. But we're going to keep that disabled for now. And this here we have this tells systemd that if our script ever crashes for any reason, which it really shouldn't because we have the majority of our script in a try except block, so most of the errors will be automatically caught and the service will keep running. But if we screwed up anywhere outside of that try block and something crashes somewhere, then systemd will pick up on the fact that the service crashed and it will restart it after 30 seconds. Here we specify which run level, which Linux run level to run our script as. So when systemd is starting up the system, there's different run levels that it enters, and multi-user is one of the main ones, and it's one of the most common ones. So we're going to tell systemd that when the multi-user run level is starting up, we want to start our script as well. So now that we have all of that, our systemd service is in place, but we need to tell systemd to actually read it and act on it. So I'm going to do systemctl start my service. So it doesn't look like it did anything, but the way that we can check if it did anything is we can do systemctl status my service. And we can see that our service is running in the background. We can see the output from it running our code. And because systemd is running it, its debug variable is set to false, which means it'll run every 60 seconds. So if I take a look at it again, it's been over 10 seconds that it's been running. It's been 26 seconds, but it's only printed one line because it's only printing every 60 seconds. So there's that. The next thing I'll mention is that this starts the service right now, but this won't start it when the system reboots. If you want systemd to run your service when the system boots up, you want to do systemctl enable my service. So this will now, if I reboot my system, then my service will run automatically. And that's pretty much it. You can take a look at the other examples, you can modify them, and one other thing that I should mention is if you want to take a look at the logs, we can do the systemctl status my service. So here we've been running for just over a minute, and it's printed the second line. So we can see a summary of the logs. These are the last couple lines of the logs. But yeah, if you actually want to take a look at the entire log for your service, what you want to do is run this journalctl, the unit, and we called it my service. And if I hit that, it'll show us all the logs that my service has ever printed out. If this is more than one screen worth of logs, it'll automatically do paging, so you can go up and down different pages. Or you can also do -f, which is very useful. If you want to watch your logs to see them live, so that as they get added to the log file you want them to show up, you do this and it'll automatically pop up. So here we can see that our service ran the first time, it ran the second time, and the third time, because we made it raise an exception, says something failed. It tried to run the third time, it raised an exception, and we can see this indentation in the logs is there, making it really easy to read. And this, when send mail is actually implemented, this won't appear. This will just be an email that gets sent. And maybe in the send mail, if the email fails to send, then this might have another additional line that says the email got or failed to send or something like that. But yeah, that's kind of the idea of how to run a Linux service and write it in Python.